Hi, this is Doug Smith in Boulder City, Nevada, and I thought I'd show you a little trick you can do with some oscilloscopes that allow you to measure a very fast signal that only occurs once in a while and see what its repetition rate is. So let's start and take a look here. This is our test setup. It's a Fisher Custom Communications EFT pulsar, which you've seen in some of my other videos. It's really great for troubleshooting problems. And I've got it sitting on top of a shorted Tektronix scope probe here. And of course that forms a loop. Built into this pulse generator is a current loop here intended for one mode of troubleshooting. And I'm just going to put over here and do some voltage into the scope probe. And we'll take a peek over here. Don't need any diagrams today. Here's our scope. It's a Tektronix MDO 4104B-6. And there's the pulse from that pulse generator when it's on, where you can turn it on in a second. We have 20 volts per division, 4 nanoseconds, so 20, 40, 60, 80, 90 volts induced in the scope. A pretty strong field coming out of the bottom of that pulsar. And our time scale is 4 nanoseconds, so it's about 2 nanoseconds wide, about a nanosecond up and down, maybe a little faster than that. So the problem is, with this, the pulse generator is going to cause for some measurements here, is let's turn it on. You can hear it in the radio over here. You can hear the pulses. Several per second, 3, 4 per second. That's pretty slow repetition rate. What if I wanted to measure that repetition rate? Let's go over here. And we're a little bit off the scale. Let's move it down a little more. Yeah, that's okay. Pretty much rail to rail here. 20, 40, 60, 80, 120, 40 volts. Quite a lot. So now let's crank this thing down from 4 nanoseconds to something like 40 milliseconds. Something like that. Now the problem is you don't see anything. You see triggering, but nothing's happening because at this slow rate, the sampling rate's not enough to pick up those really fast pulses. So how do I measure that? You go over here to the acquire menu, and then the mode. Here we go, mode, and you go to peak detect. And now you can see we're 40 milliseconds, 40, 80, 120, 160, 200. I may have did that wrong here. 1, 2, just kind of 1, 2, 3, 4, 5, 6, 7, 8, 9. The whole screen is 10, so the whole screen is 400 milliseconds. So we're a little bit faster than twice per second. I can speed that up a little bit if you like. Some of that variation in amplitude is sampling, and some of it's in my pulse generator. We can go maybe 100 milliseconds. There we go. So now we have 200 milliseconds. So it's going 5 times per second roughly. And I can slow it down and you can see it. But that's a very fast pulse. And normally you can't pick it up at this speed because we only have a 1 kilosample per second sampling rate at this very low speed of 100 milliseconds per division. But that's a little trick you can use to pick up your sampling rates. Get this off over here. And thought you might like to see that. A lot of Tektronix scopes have that. This again was an MDO 4104B-6, which has the built-in spectrum analyzer. A great instrument, which I use quite a bit here in the lab. And this is the kind of thing I demonstrate in my courses: measurement techniques, troubleshooting techniques, EMC, ESD design, troubleshooting, all kinds of stuff. And got one. This is right. Actually, today is August 5th, and the last week of this month I have a course coming up here in Boulder City with these kind of things. And a virtual course runs half a day each for 4 days. You might enjoy it. Very inexpensive, cheaper than an airplane ticket would be, a low-cost airplane ticket even, to get here. Okay, thank you very much, and see you on the next video.